Find all zeros and a complete factorization of p of x equals x cubed minus 2x plus 4. The tricks that we used in the last couple of problems, namely a difference of squares and z substitution for something in quadratic form, won't work here, so we have to use the rational zeros theorem to figure out the possible rational zeros and then use synthetic division to determine one of those. So here we know that because the leading coefficient is 1, the rational zeros must be factors of 4. So we're going to have 1, negative 1, 2, negative 2, 4, and negative 4. Now, the way to proceed here is to try synthetic division on all of these possible zeros until you get one that works out, one that doesn't have a remainder. But because I want to keep these videos short, I am going to skip the ones that I know don't work, and I'm going to jump straight to negative 2. So let's demonstrate that negative 2 is a 0. So we put in the coefficients of the polynomial 1, 0, because there is no x squared term, negative 2 and 4, and let's go through the synthetic division process. 1 times negative 2 is negative 2. We add and get negative 2. Multiply that by negative 2 gives us 4. We add and we get 2. Multiplying by negative 2 gives us negative 4. We add and we get 0. So our polynomial has negative 2 as a 0, which means it has x plus 2 as a factor. And when we pull that out, we're left with x squared minus 2x plus 2. Now this is not something that can be factored easily using unfoiling. So to find the zeros that correspond to that, we're going to use the quadratic formula. So we've got opposite of b, which is going to be positive 2, plus or minus the square root of b squared. Negative 2 squared is positive 4, and then minus 4 times a times c, all over 2 times a. Now underneath that radical, this is going to end up being 4 minus 8, and 4 minus 8 is negative 4. So we've got 2 plus or minus the square root of negative 4 over 2. Now the square root of negative 4 is going to be 2i. And when we divide both of those by 2, we get 1 plus or minus I. So the zeros for this polynomial are going to end up being negative 2. The zeros are negative 2. And then 1 plus I, and then 1 minus I. Now, if we are going to have a factorization, each of these zeros is going to correspond to a factor. So negative 2 is a 0, is going to be x minus negative 2, which is the same as x plus 2. 1 plus I as a 0 is going to be x minus the quantity 1 plus I. And then 1 minus I as a 0 is going to correspond to x minus the quantity 1 minus I. And we can simplify these by distributing the subtraction in each. And so we've got x plus 2 times x minus 1 minus I times x minus 1 plus I, and this is our factorization. So we've got a complete factorization, and we've got the zeros, and we're good to go.